Hello everyone and welcome back. So in this video we're going to turn our attention from value noise 2D over to value noise 3D, and this will be implementation part 1.
Right. So we're going to go into our code. If I can get the little bar to pop up. Come on, you can do it. There we go. All right. Now, just like with 2D noise, we need to do this in two parts. We've actually got the noise part of it, and then we have to come up with this smooth noise, which is what takes our random noise or our hash noise and then smooths it out before we feed it into the rest of our noise algorithm. So we're going to be creating a 3D version of this smooth noise. Now, let's go ahead and copy all of this code because it's pretty much the same. And we're going to paste it here. Now, because this is going to be 3D noise, we need to be able to handle a Z component, which means we're going to have to change all of these to be hash 3D. And try to do this in a way where I don't have to deal with IntelliSense and all its little nonsense popping up and getting in my way. All right, now we have to deal with the Z part of this. Now, so we're going to start off with Z being at its low component, which is going to be Z minus 1. Then we can copy this. For the first 4 here. We can also copy it down here. And then for our center sample, we're just going to use Z. Now we need to double up the corners because now we're talking, instead of looking at a unit square, we're looking at a unit cube. So all of this needs to be duplicated. Hit plus, paste this. Now instead of Z being minus 1, we're going to have to add 1 to it. So this will give us our high points. So this gives us all 8 of our corners. And then if I take these 4, copy them, and then paste them, and again change this to plus 1s, these will give us our sides. Now, if you look at a unit cube, or if you imagine a cube, our cube has the 4 corners, but in between each one of those 4 corners is an edge. Actually, I'm trying to think. You want to bring up Maya? We can explain that with Maya a little bit easier.
Yep.
Another visual.
Okay, there it is.
All right, cool. Thank you. All right, we're going to do this simply by going into Polygon, turning off interactive creation because I know you have probably not used Maya yet.
Since the install, no.
Yeah. So we're going to create a cube. So this gives me my cube. Now I want our cube to be divided by 2. Or no, I want this 1. I want it divided by 2. I know how to use Maya. Really, I do. There we go. All right, now, if I frame up on this, we make it solid. So here's our cube. Now, our cube has 8 sides, which we explained, or 8 corners, which we explained. Now, if you look at the sides, we've got a, in between each of these corners, we have an edge. And halfway in between that edge is our sample point for our side. So we've got If I bring up vertices, we've got a side here, we've got a side here, a side here, a side here. That makes up the top sides. Likewise, our bottom faces have points here. And that gives us 8 sample points.
Mm-hmm.
Those are the 8 sample points that I'm using right now. If you wanted to model this as realistically as you could take all of the other points as well, halfway in between, which are, these additional 8. So then you would have 16 points in total
Mm-hmm.
for a really accurate representation of what's going on. The only problem with that is we've already proven that just sampling 9 times is really intensive on the system. Doing an additional 8 samples on top of everything else is just going to really complicate things and slow it down. So we're really not going to model out every possible side. So we're just going to do those initial 4 on the top of the cube and the initial 4 on the bottom of the cube and interpolate between it. And it'll give us a representation, while not 100% accurate, is a nice trade-off between speed and accuracy.
Mm-hmm.
So we'll still keep our 8 for our corners. We're going to multiply this by, or divide it by 32 instead. We're going to take our 8 sides and divide this by 16. And we're going to keep our center, and we're going to return it divided by 4. So we'll keep all this the same, or the center the same, and just modify our corners and sides. And we're going to return, it's still going to be exactly the same, corners plus sides plus center converted to a float. That gives us our 3D smooth noise. So if I build that out, we should be good to go there. If we go back over to Game Manager, and go ahead and comment out all of this code for now. And uncomment that line. Let's take our division by 4 out. I can get rid of our cast integers as well. And let's take Z, and for now we're going to make this just 0. I'm going to hard code it in. Also want to take our time down to about 2 seconds. I want to bring our sample size down to 128. So if I build that out, go back over to Unity, cross my fingers, hopefully we get something out. So now we've got a 3D noise. Looks a lot like our 2D noise, in fact. So, and we're at about a little over 1 second, which is kind of acceptable for what we want to do for now. So go ahead and pause this, or stop it, not pause it. Go back in the code. So I know that it's taking just over a second to run. So I can set my timer to about 1.5 seconds. We shouldn't get any collisions with the update and update noise. Now, if I go ahead and take our iterations and put that in, and what are you not happy about? It's not a small to primer type integer. So, oh yeah, that's right, I gotta cast it. Which means I'll probably just add this by 1 because it's gonna complain anyways. All right. So if we go back to our Unity and run it, we should see some changes about every second and a half.
And we are.
So the problem that we've got is because this is smooth noise and all we're doing is smoothing our base underlying noise and we're doing our iteration, we're still seeing a lot of the jumping. We're not seeing a progressive, smooth iteration as if the noise was crawling
Mm-hmm.
or shifting or morphing, whatever term you want to use. But that's to be expected because we're just dealing with noise. But it does show that we are using a 3D smooth noise as opposed to the regular noise. So we've got that part going back in the code. So that has what I wanted to implement as far as smooth noise. In the next video, what we're going to do is come back, take our value method and modify it to function with a 3D variation of it. So we're going to take this code, duplicate it out, and then add to it the stuff that we need to make it work
Okay.
for a 3D noise.
Okay, fantastic. Well, with that, that is going to wrap up this video. Thanks a lot, everyone.